All right, happy afternoon or morning or whenever you're watching this, everybody. This is again just a tutorial video, somewhat short one, I hope to make it, about how to just do the calculator portions. So we're talking on the TI um, portions of the modeling skill, which isn't many of these questions, but it is, maybe one of the harder elements. We've used Desmos in the past, but for next year, I want to make sure you guys know how to utilize specifically your TI in the hopes that, we're back in the building or whatever using our TI-84s, right? So this is off of worksheet 1. And if we look through number 1, this was a rather long problem. It had parts A through I. And the parts that you actually need the calculator for in terms of the graphing functionality of the calculator isn't until really part E, A, or not A, F, let's see, G, and some other parts here, right? Really any part where it says like the maximum height. So I do want to show you how to do this on the calculator. You crack open the TI-84. Let's try to get in the light here. I think this should be pretty good. Maybe right about there. All right, so what we can do, let's clear this out and enter the y equals functionality up here. Clear anything that might be in there. And what we're going to do is we're going to type in the problem itself there. So it's, what is it, negative 16x squared plus 79x plus 5. All right, there we go. It's in there. Notice I replaced the t's with x's just because that's how the calculator takes inputs as x's. We will then press the graph button over here, and there it is, or there it is sort of, right? You can see parts of it is kind of coming up through here. It goes way off the screen and comes back down here. So as you could see, well, I mean, there's a couple things we could see, right? It's kind of crossing somewhere around 0 and somewhere around 5. Now, how can I confirm that that is exactly 5 and not 4.99 or something? Well, I can go to the blue button here and then press graph again, and it brings up the table. And you could use the arrow pad to go up and down here. And as you can see right there at 5, that's confirmed it crosses at 0. And at 0, it's at 5. So that means it's not quite crossing at the origin, but I'll show you how to find that, that point shortly. All right, so what I'm going to do is, again, let's go back to the graph. Like I said, you can't see the whole thing. It'd be nice to see, all right, where is this thing up here? Well, what I can do is adjust my window, right? So by adjusting the window, or how you do that, is you're going to go into the window button, and we can adjust the window with these first two and the fourth and fifth item there, the things that say Xmin, Xmax, Ymin, Ymax, right? So those things we can change. I think the first day we went over all this, I did mention the fact that almost always on these problems, we care mostly about the stuff in the first quadrant, right? So, I mean, if you have something like this, we're talking first quadrant. Well, that means the smallest we're going to go in the x direction is 0. So we could actually get rid of that negative 10 in that first slot and put 0. And then we're going to go over and say, okay, how about the y-min? Well, very much the same thing. We only care about down to there. So that's going to be 0 in there. All right, how about the x max? Well, remember when I said it hit the x-axis at 5? That means anything bigger than 5, we don't really care about too much. So a good x max might be about 5. Now, usually the hardest one to determine, or what you should do to, to get the window, is the y max. It's always more difficult to say how high up should I go. One thing you can do is be like, okay, 0 to 5 are my inputs. Let's look at my table real quick. 0 to 5. There's at 0, it's at 5. At 5, it's at 0. Okay, so everything in between, these numbers are really the stuff we care about. Well, what's happening here? Well, it's going 5, 68, 99. Then it starts coming back down. So we could probably determine that it probably doesn't go past 100 too much, right? I think the end answer is like 102 something. So just by kind of analyzing this table, we can get a pretty good idea about what our y max should be. So let's go to the table rather here, or the window, sorry, the window again. And let's set that y max for, I said a little over 100, let's put it at 110 just to be safe. Let's see what that's about. If we press graph, we could see it very nicely fits in the window now. We can really see the part we care about, which is right up here. All right, so how do we find out exactly what that point is? You don't want to guess, obviously, because you're not going to be able to guess too accurately what this is. But there's, again, functionalities on your calculator that will allow you to find this with relative ease. All right, so what we're going to do is go second, trace. Now this that sequence of buttons brings up a menu in which you can go down to option 4 where it says maximum. We're going to press enter on that. And you might notice right here, it poses a bit of a question to you. It says left bound. Well, what I'm going to do is I'm going to type in on the, the numbered keypad down here, the furthest left point on my graph. Well, what this is going to correspond to, I don't know if you remember, but in the window menu, we had X-min and X-max. Well, the left bound is going to be your X minimum, right? So remember that was 0. So let's just type in 0. Notice how that came up right there, 0. And then press enter. And now it says right bound. How far right do you want me to check, right? Because what it's going to do, it kind of has like two little arrows, right? And let's say you put the arrows at 0 and maybe 1. What it'll do is it'll find the biggest point between 0 and 1, probably somewhere up there. But what we want is the biggest point between 0 and, remember this one, 5. So 5, and if I do that, what the program's going to do is go right up there to the center, right up top. It says guess, that means just press enter a third time, and there you go. So the biggest thing it achieves is 102.5 at about 2.5 seconds, and we saw that with the work we did, right? There's 102, about 2.5 right there. All right, so I just wanted to give you an example of that on your calculator. Let me go through a couple more just in case we need it. All right. So how about this one? If we type this one in, this will be a bit of a different one, so this will be kind of good to see. Let's clear that out and type in this. So 2x plus, we'll call it 400 over x. 2x plus, and then do that. Oh, and by the way, what I just did there, I should probably mention that. This is an older calculator, so yours will probably definitely do it if you have the new colored one. But if you press the green alpha button and y equals, and then press enter on the first option, you get a fancy little horizontal fraction bar. Kind of makes typing things look a little better. So it was 400 over x. And there it is. And we're going to press graph and see what it looks like. All right. Well, we get a little sneak peek of it over here. So obviously we got to do some adjusting of our window. So we're going to go window to adjust it. Like I said, we probably care only about the first quadrant, so I'll keep my X-min there and my Y-min also there. Now X-max and Y-max. Well, let me familiarize myself with this problem again. Okay, so this thing, okay, X in this problem represents the width here, right? So the width obviously can't be less than 0, so that's why the X-min is 0. But then, again, how big could it be? Well, if we have, let's see, 200 square feet, remember, we're just talking numbers that multiply to 200, right? So like 10 times 20, maybe it's 100 times 2. 200 times 1 would be a pretty extreme looking rectangle, right? So any numbers in there. So how about we put our X max at, I don't know, how about 200? How about we do that? That would be a rectangle that is 200 feet long by 1 foot long. Kind of a goofy looking one, but it would, would do it. And then the Y max, always the trickiest one, right? So let's think about this one. This one's a little tougher. Let's say this was 1, right? If this was 1, then we would have 1 times 200, right, to get our area. But the actual perimeter would be 200, 200, 1, and 1. So like 402 or something like that, right? So that's a pretty big perimeter. What would happen? Let's do some other examples. How about 10? Throw 10 in there. You'd have 10, 10. This would go to what, 20? So 20, 20, that's 40, 50, 60, right? So your perimeter is 60. So, playing around with those numbers, it seems, right? And you could do some more examples to get a feel for it. You obviously see the answers here, but again, we wouldn't know this in the very beginning. All right, well, I did one example, kind of that extreme example where the perimeter was like 400 something. And then I did kind of a more reasonable looking rectangle, and that was like, 60 something. So how about we, let's put it at 100, right? Because obviously we want to minimize the perimeter, so we don't care about the really extreme examples like that are going to be all the way out on the graph. Let's put it around 100 and see what that does for us. We might have to adjust it, but let's put it at 100. All right, that's not bad. That probably could have been better, the window I chose. It's probably a bit too long in the X direction, but it's enough to party here. All right, so we got this little piece up here. We want to know its minimum value, right? So right down there. So in very much the same process as the first problem, we go second, trace, go down to minimum, right? Not maximum, but minimum this time. And now it says left bound, right bound, right? So once again, if you remember, our left bound is our furthest thing over here. Since we're in the first quadrant, let's call that 0. And how about to the right? Again, honestly, you could choose any of these numbers in here, but if you recall, the furthest right I went on my window, I believe, was 100. So I'm going to type that in there. And then what it's going to do is say guess, do it one more time, and there we go, right? So the minimum perimeter, let me get that more in the light, 56.5, 56.5. The X value that did that for us, 14.14, 14.14. And then to get this value, you're going to say, okay, 14.142, that's this. To get my length, do 200 divided by 14.142, and it happens to also be that. The answer to this happens to be a square. Not always the case, but for this problem it is. So don't always assume it's a square. So there's that. Let's see. Maybe let's do one more together here. How about we do, I don't know, I guess this one's fine. X times that stuff. So let's go to y equals, clear that out. We have x times 80 minus 2x. And I could do the green y equals button, press enter, and it gives me that fancy fraction. Oh, it did it wrong. Let me delete all this and try this again. Oh no, everything's going wrong. We're going to just start again and act like that didn't happen. X times fancy fraction right there. Do it first. 80 minus 2x over 2. Close that up. Let's see what we get here. All right, so we got something going on there. Obviously, our window's a bit off, probably too large. Definitely in the X direction, maybe not tall enough in the Y direction. We'll see what this is about. To get the window correct, you might want to engage with question C, because remember, the domain is going to tell you that your X min and X max. In this one, it was 0 and 40. If you're unsure why it's 0 and 40, always look to the problem itself. This is in factored form. That little x, that monomial, that one-term thing, that's a factor. And this thing in here, that's a factor as well. So just think, what is going to make these two factors 0? What makes a singular x 0? Well, 0 will do that. What's going to make this fraction 0? Well, it's going to be whatever makes the numerator 0. So 80 minus 2 times what is 0? 40. So that's how we get that. So that's helpful. So I load that in there, 0, 40. The y min is also 0 because we're dealing with first quadrant stuff. And now we just need to deal with your my y max, which I believe was too low. right? So let's look, what is this problem? I already kind of forgot. All right, so it's gonna be another, let's see, area problem, right? All right, so again, 0 and 40 was my min and max on my x direction. This thing's gonna be a parabola, an upside down parabola. So think about what happens exactly in between my two x-intercepts, because evenly spaced between my two x-intercepts is going to be my vertex. So it's going to happen at 20, and actually that's the answer. But let's say we didn't know that. Let's plug in 20 into this thing. So 20 times 80 minus 2x over 2, 20. So that's 400. So we could put my y max at, let's say, a little more than 400, just to give it a little breathing room. Press graph, and look at that, it's beautiful. All right, so parabola, right up there's the vertex that I want to address. So once again, I do that, and feel free to pause this and do it with me if you're having trouble with this particular concept. We're going to go second trace. This is a maximum, so that's option 4. And then we're going to go left bound. Remember, this is basically the domain values. Left bound is 0, press enter. Right bound is 40, press enter. Then it says guess, that means just press enter one more time. And look at that, okay? When it does something like that, sometimes the calculator isn't exactly on, but we could assume that that's 20, 400. And as you can see, the maximum value was 20. And the dimensions that yielded that were 20, because that was the x value. And then we got the other 20 from going 80 minus 2 times 20, which is 40, divided by 2, which is 20. So this one also happens to be a square. All right. What else we got here? All right, this one's kind of neat. I said the last one was going to be my last one, but I'm having too much fun, so I'm not going to stop. We have this one over here. This one's actually going to be a very, this one's going to look pretty nice actually in the window. So if you go up here and we type in what we just saw, which was 2x times 10 minus x squared, 10 minus x squared, close it off, and then hit the graph button over here. All right, you might think there's nothing there, but it's actually all the way down there. And honestly, you could actually do all the work for this from this window, but that's a little, that looks kind of bad. So here's what we could do. It's always a good idea to maybe get back to what they call the standard window, which is 10 by 10 in every direction. And you can actually do that quickly by going to the zoom button and then pressing number 6, or scrolling down to 6. All right, and there we go. This thing is a cubic, as maybe you noticed, so it should be an N-shaped graph, or in this case, kind of a backwards N. And it's almost in frame. We just have to go a little higher up in this direction. So how about we adjust our window? We're always putting it at 0 and 0 for my mins. And the x max. Okay, well, x max, that's going to be domain stuff, right? So domain, it'd really be the answer to D down here, but you could do this in any order, right? I might do this question first before I do these two. It's the square root of 10, right? So how would I know that? Well, again, remember we're back up here. That's a factor, monomial, a single term item, binomial. And you're just asking yourself, what makes both of these items 0? Well, the one on the left, 2 times something is 0. Well, that something must be 0. So that's the thing on the left. And then this one, maybe a little less obvious, but if you were to do this, 10 minus x squared equal to 0, and just start solving, continue to solve a little more, and get the square root of 10. Now, technically, it's the positive and negative square root of 10, but like I said, we only care about the stuff in the first quadrant, so we will exclude the negative root 10. So there we go, root 10. And if you put root 10 in your calculator, it's about that. So you could use kind of either one of these values, although this one would be the more precise value. All right, so I'm going to save that, and you could type in something like that in there, square root 10. To get a square root, you do second and the x squared button if you weren't sure. And now we just need to do the y max. Always the trickiest one, right? But let's remember what this problem is asking, right? Where it's all about the areas of rectangles you could fit under here. So remember these few examples we did? We had like one that was like 18, 24, and those were pretty large ones, right? As we get a little shorter and stouter, we'd probably have, like if we had it at like 3 here, it'd be a pretty low riding one here. It'd be a area of 6. This one was 18, 24, so we're probably not talking super massive numbers here. Probably numbers under 30, I'd say. So let's do 30 as our max. And that could vary. It doesn't have to be exactly 30. You could have done 40, 50, 32, just something that so that the entire graph fits. Let's see what this looks like. Look at that, like Christmas. All right, so there it is. And we want this value up here, right? So second, calculate, and maximum. Move it into the light a little more. All right, so left bound was 0. Right bound was the square root of 10. Remember, this comes from part D. The domain is the easiest way to do this particular part. Oh, invalid. Let's see. Maybe it doesn't like square roots for that stuff. That's all right. The square root of 10 is about, what do we say? About 3.2. 3.16 something. Let's just call it 3.1. All right. I think I pressed the wrong button. Let me try that again. Maximum 0. Enter. Shoot, I think I just pressed the wrong button again. Maximum. Left bound is 0. Right bound is 3.1. Guess. And there we are, right? So right there at about 24.3 at an x of 1.826 or something like that, right? And we see that reflected here. There's that 24.343 number. 1.826 is being doubled because of that. The width is actually twice what the x value is. So if you take that 1.8 number and double it, you get that. You get this 6.66 number by plugging the 1.826 number into just that part, 10 minus 1.826 squared. There it is, right? But again, the main purpose of this video was to just familiarize yourself with the TI functionality on your calculator. This is, again, for the most part, I know we used Desmos last time, and that's a great resource to check your answers, but for like future things on ACT, SAT, pre-calculus next year when hopefully we're back in the building full time, you'd want to know how to do it on here. And we might have, a calculator only skill check or something like that in the future as well. So you can refer to this video, or if you need extra help, let me know. Email me. We can make something work. But that is going to be it for now.